Today you're going to be learning about a fourth type of transformation called a dilation. So far you've learned about translations, which slide a shape across the coordinate plane, reflections, which flip a shape over the line of reflection, either the x or y axis, and rotations, which turn an object around the origin of a coordinate plane. Today we're going to be talking about dilations. Go ahead and fill in the blanks as I'm reading along. The image produced by reducing or enlarging a figure is called a dilation. To complete a dilation on a coordinate plane, simply multiply each coordinate by the given scale factor. You should notice that the shape will either move closer or further away from the origin, as it acts as the center of dilation in this case. A scale factor less than 1 will produce a smaller figure that is closer to the origin. It makes the image shrink. And a scale factor greater than 1 will produce a larger figure that is further from the origin. It makes the image grow. So I'm going to do examples 1 and 2 with you, then you're on your own for 3, 4, and 5. We'll be around to help you out. For number 1, we're going to start by graphing P. So we graph 0, 8. So for 0, 8, we stay at the origin and go up 8. Make sure you're labeling as you're graphing. Then -4, -4 for E, so left 4, down 4. And +4, -4 for N, so right 4, down 4. And then neatly take a ruler or a straight edge and connect your points. It's very important that when you're transforming a shape on a coordinate plane that you're super, super neat. So now we're going to dilate it with a scale factor of 1/4. So in the directions, you saw that the only thing you have to do is multiply all the parts of the coordinates by the scale factor. So remember, when we're rewriting the coordinates after a transformation, we use a prime sign. So P prime in this case is going to be 0 times a fourth. Anything times 0 is 0. And then 8 times a fourth, which is like dividing by 4. So 8 divided by 4 is 2. Then we go on to E prime. -4 times a fourth is -1. -4 times a fourth again is also -1. And then N prime, 4 times a fourth is 1, and -4 times a fourth again is -1. So we go ahead and graph those points. We have P 0, 2, P prime, E -1, -1, and N +1, -1, resulting in a much smaller triangle that is a fourth of the size of the original triangle. So now we no longer have congruent shapes. We have what are called similar shapes because they're in proportion to each other. They have the same shape but different sizes. So taking a look at number 2, we're going to do the same thing. We're going to go ahead and graph quad. We have -4, -2 is Q. -4, -4 is U. -2, -2 is A, and -2, -4 is D. So I know I graphed these out of order, but go ahead and graph them as if it was a square. Okay, and then we're going to dilate it by a scale factor of 3. So we're multiplying all the coordinates by 3. So Q prime times 3 is going to be -4 times 3, which is -12. -2 times 3, which is -6. U prime, -4 and -4 both times 3 give me -12, -12. A prime, -2 and -2 both times 3 gives me -6, -6. And D prime, -2 times 3 is -6, and -4 times 3 is -12. Now we can go ahead and graph those points. So -12, -6 is left 12, and then down 6. Make sure you're labeling Q prime to show that one transformation has been done. And then -12, -12, left 12. And down 12 is our U prime. Then A prime is -6, -6. And then down 6. And D prime is -6, -12, all the way down to the bottom underneath the A. Again, connecting to form a square. And we have a square that is further away from the origin and 3 times the size of the original QUAD that we graphed, creating again another similar shape, no longer congruent because they are the same shape but different sizes. So you're going to go ahead and do the back side of the worksheet on your own, and I'll be around to help you out.